All right, guys, here's all the answers for that one, for the quiz. Hopefully you guys do good tomorrow. Okay, this one goes, he earns $1, but it takes him 2 days. So he's making $1 every 2 days. So his slope is 1/2. So he's making $0.50 every day. But if they tell you how much he starts with, you don't have to do the math. On day 0, he started with $4. So there's the equation. This one, he goes up $1 every 2 days. So y equals, same thing. He makes $0.50 a day. That's what this means. That's his slope. That's how much he's making. He's making $0.50 every day. So if he made $0.50 every day working 10 days, he should have $5. But, so 5 times 1/2. But for some reason, he's got 9, which means he started with $4 in his pocket. There's this extra $4 that we can't account for. Basically, you take your x, you multiply by whatever the slope is, so multiply by 1/2, you get 6, you need to go to 10, we need to add 4. All right, over here are all the ones that I labeled weirdly. Okay, A is a do nothing, right? He starts here, but he doesn't do anything. So when I make my equation, y equals, there's gonna be no slope because he's a do nothing, so the slope's 0, so I don't even mention it. And where does he start as the baby's laundry? He starts at -1, 2, 3, 4, 5, 6. So that's just the equation right there. Y equals -6. Now you don't have to do it with the shapes, but I'm just helping you out. B is going up and going up $1 every 1, 2, 3, 4, 5 days. He's going up $1 every 5 days. So his equation is y equals, do not forget the x, 1/5 x. My laundry gets the x. I'm extra large. And I start at 0, right? This guy starts not in the past, not in the future. He starts at 0. So if there's a 0 in the laundry for the baby's laundry, we don't mention it. So it would just be y equals 1/5 x. In the future, you don't need to cross these out. Just don't write them. C, this guy's going down. He's losing money. In the future, he's getting poor. So he's losing $1 every day. So if you ever do something every day, that's your score. So he's losing $1 every day. We don't put divided by 1. Just like I said, when I say I'm 41 years old, I don't say I'm 41 once years old. We just say 41. So over here, we just say -1. We never put 1s in the bottom. So if my slope is -1, I'm going to put -1 in the box. But whenever you are writing with a variable next to a letter, we don't write 1s. Just by seeing the letter, that means 1x. So -1x looks like that. Where does this guy start? He starts at -1, 2, 3, 4. So right now he's starting at -$4. So there's that guy. D is the guy stuck in time, right? He's undefined. We don't have a name for this. He's not getting better. He's not getting worse because he's not moving into the future at all. He's stuck on that day. Notice this little x. Kind of in graphs, x is the timeline. So we just have to say he's stuck on the graph. He's stuck on the x line at 1, 2, 3, 4, 5, 6, 7, 8. He's stuck in time on day 8. So the undefined one is the only guy who doesn't look like the rest of them. He's not y equals my laundry, baby laundry. All right, these ones, super easy. I've got 4 x's and -1x. So really I have 3 x's plus 2 on this side. I have 3 x's minus 2 on this side. The 3 x's are going to cancel each other out. First thing I'm going to do is just look at the x's. If they cancel each other out, then I look at the numbers. These are different numbers, -2, +2. These are never equal. Over here, I start with the x's. I've got 4 x's on this side, 6 x's on that side. Those are different. They're not going to cancel out. This is a normal problem with a normal answer. Over here, I do my Starbucks, my distribution, 2x plus 2 equals 2x plus 2. Then I look at the amount of x's. There's 2 x's on this side, 2 x's on that side. They're going to cancel each other out. And we're left with 2 equals 2. That's always true. This is the trick question I keep giving you. This is 6 x's. This is a -6 x's. Those do not cancel each other out. This is a normal old problem. One answer. All right, over here. These are the hi, hello problems. These are, this word means hi. This word means hello. They don't look alike, but this equal sign says don't worry about it. They're the same. So I can rewrite this sentence below, taking out the word hi and replacing it with the word hello. And if you write the rest of the sentence exactly the same, you didn't change the sentence. it still means the same thing. All right, so let's do negative 2. We've got 2x down here. We have negative 2 times 3x is negative 6x. Negative 2 times negative 7 is positive 14 equals 6. So we've got too many x's over here. 2x's minus 6x's. Let's put them into 1. Negative 4x's. Let's minus the 14 and move it over here. So negative 4x's equals negative 8. Divide by negative 4. The negatives cancel each other out, and x equals positive 2. X's equal positive 2, so I'm going to come back up here. If x's are 2's, then this is y equals 3 times 2 minus 7. 3 times 2 is 6, minus 7, y is negative 1, so the answer is 2, negative 1. Over here, I need 2 of the letters to cancel each other out. I'm going to turn the x's into 4's, but I need one of them to be negative. So I'm going to multiply this one by negative 2. What does that do? It turns positive 2x's into negative 4x's. It turns negative 2y's into positive 4y's because negative switches you. And it turns positive 2 into negative 4. Now I'm going to let them fight against each other. 4x's minus 4x's are dead. 3x's or 3y's plus 4y's is 7y's. And 18 minus 4 is 14. So when I divide by 7, y's are 2's. Let's see, what's the easiest one? So if y's are 2's, I'm going to say 4x's, come on, Apple Pencil, 4x's plus 3y's equal 18, but x's or y's are 2's. Make sure I plug it in the right one. So 4x's plus 3y plus 3 2's is 18. 4x's plus 6 is 18. I'm going to minus the 6. 4x's equal 12, divide by 4. X's are 3's. So this is 3, 2. Always x first. Over here, there are only 2 different styles of angles over here. I'm going to call them red angles and blue angles. Let's say I call this a red angle. The one that's on the opposite side of the x will always be the same because they're called vertical angles, which means these 2 also have to be the same because they're on the opposite side of the x. Whenever you have 2 parallel lines cut by one line, all the answers for this top intersection are going to be all the answers for that bottom intersection as well. So they're copies of each other. So this is going to be a red angle because it's the matching angle. So is this going to be a red angle? And this is going to be blue, and this is going to be blue. So we really only have 2 angles down here. We have red angles and blue angles. Another thing I know is that red angles and blue angles make a straight line with each other right here, right? This is a straight line. So this angle and this angle, red angles and blue angles make a straight line, and straight lines have 180 degrees. Okay, let's see what I can figure out first. I can't write an equation with 2 letters in it and work it out. So I need to try to make an equation with only 1 letter in it. I see this has x's and this has x's. If I know how these relate to each other, and I can only use 1 letter to do it, I can figure this out. So they're both red angles, which means these 2 angles are equal to each other. So the angle 3x is equal to the angle 5x minus 40. If I subtract 5x's from this side, it turns out negative 2x's equal negative 40. Divide by negative 2. It turns out x's are just 20s. So x's are 20s. Okay, so if x's are 20s, right, x's are 20s, then this angle over here is 3 times 20 is 60 degrees. So all the reds are 60 degrees. 60, 60, 60, 60. Which means all the blues have to be 120 because the reds and the blues add up to 180 because they make straight lines. So all the blues are 120. So over here, this 2y's is 120. 2y's equal 120. So when I divide by 2, y's are 60s. Over here, this angle is just, C is just 120. So you have to know a couple pieces of information for these. That all the reds are the same, all the blues are the same, and the reds and the blues add up to 180. That's all you need to know. Over here, you need to know that there's 180 degrees in a triangle. So if I add up this 19 plus this 40 plus these 11 x's, I know that should be 180. So let's see. 59 plus 11x equals 180. All right, minus 59. Minus 59. 11x's equal 121. Divide by 11. And x's equal 11. So x's are 11s. So I know this angle right here it's not 11, it's 11 times 11. So there's 121 degrees right there, which means in this straight line, y has to be 180 minus 121 or 59 degrees because it makes a straight line with this guy. If you want a really quick shortcut in these kind of pictures, if you think about this, these two added together will always be the same as this one. If that makes sense to you, you're pretty smart. All right, so 59 degrees. Over here, exponent rules. One less than subtraction, there's no way to simplify it. Or one less than addition is nothing, there's no way to simplify this. To simplify this, one less than multiplication is addition. We can add those, x to the 5th. One less than subtraction is nothing, so there's nothing we can do to simplify this. One less than division is subtraction, so 2 minus 3 is negative 1. Or if we're not supposed to put negative fractions, we just put it on the bottom. And anything to the first power is just itself, so any one of these could be the answer. All right, here we have powers to powers, and we've got one less than powers is multiplication, so this would be 3 times 2 is 6. Over here we have powers of powers, so this would become 1 less than powers is multiplication, 2 to the 14th. Divided by 2 to the negative 3rd. 1 less than division is subtraction, so 14 minus negative 3. 14 minus negative 3, when you try to subtract a negative, it makes it, by Starbucks, it makes it positive. So this is 2 to the 17th power. Let's see. Write these in scientific notation. Scientific notation, you have these normal parts of the number, and it wants us to do multiplication, so we're going to do normal multiplication. 3.1 times 4 is 12.4. And then the powers over here, we can use powers shortcuts to do this powers multiplication. So 1 less than multiplication is addition, so this is 10 to the 7th power. If I try to trick you, this is not the right answer, even though it looks like it, because this number is not between 1 and 10. So we're going to make this number 10 times smaller by moving the decimal back 1 and changing 12.4 into 1.24. But if we made that 10 times smaller, then we have to make this 10 times bigger to even it out. That's actually the scientific notation. This might be an answer, and if they say what answer, if that's an option, you can pick it. But if it says specifically put it in scientific notation, the first number has to be between 1 and 10. So the decimal has to go after the first number. 12, write this in scientific notation. Okay, if I was trying to do this, the reason this breaks is because normal numbers, I can add normal numbers. Normal numbers, normal adding would be 6.4. But when I try to add powers, 1 less than addition is nothing. So there's no way for me to do this section. So that means to do this problem, I have to take the long cut. And the long cut means turn them into normal numbers. So 2.3 times 10 to the 3rd, I move the decimal over 1, 2, 3. This is 2,300. 4.1 times 10 to the 2nd means I move the decimal over twice. So 4.1, boom, boom. This is 410. If I add those up, I get 0.172. This is 2,710 is the right answer. If I want to turn it back into scientific notation, I say 2.71 times 10 to the 3rd. I put the decimal after the first digit and I would have to move it 3 times if I wanted to get there. So there's no quick way to do that. What's the distance from these? Let's see, 5 to 9. If this guy's on day 5 and this guy's on day 9, they're 4 days apart. So there's my a squared. If this guy's got $12 and he's got $14, they're 2 days, they're $2 apart. So if I was going to draw like a triangle of how far they are apart up and down, it'd be 2. How far they were apart sideways is 4. So you're just making a triangle. That makes a triangle. So let's figure this out. 16 plus 4 equals c squared. So 20 is c squared. Take the square root. They're the square root of 20 away from each other, but what is the square root of 20? There's a couple ways you could do this. You could tell me exactly that this is the square root of 4 times the square root of 5. Ooh, my pencil. Square root of 4 times the square root of 5, and this is 2 root 5. That would be simplifying the answer. If you were to estimate the answer, I would have to say this is between 16 and 25. So this is between 4 and 5. And it's a little bit closer to 4, so this is like 4.5 or 4.4, somewhere in there. So either one of these answers would work. Let's see, simplify this. Simplify doesn't mean estimate. This means this is the square root of 100, which is a pink number, times the square root of 5. 100 is 10, and then 10 times the square root of 5. 63. I could work down 49 doesn't go into 63, 36 doesn't go into 63, 25 doesn't go into 63, 16 doesn't go into 63, but 9 does. Square root of 9 times the square root of 7 is 3 root 7. There we go. How many times larger? How many times means like how many times bigger am I than somebody? I'm twice as big. We're dividing. So 9 times 10 to the 4th divided by 3 times 10 to the 3rd equals 9 divided by 3 is 3. 1 less than division is subtraction, times 10 to the 1st. That's just 30, right? 3, move it over 1 time. So you could write it in scientific notation. You can write it in normal. So it's 30 times bigger. That's how many times bigger that number is than that number. But how much bigger is it? Let's see. We're going to do how much bigger is something, you have to do the long way. You have to do, this means subtraction. How much space is there between the two? How much bigger is it? Since there's no shortcuts for this, I have to do 9, move it over 1, 2, 3, 4. That's 90,000. And 3, move it over 3 times. 1, 2, 3. This is 90,000 minus 30,000. This is 87,000. If I wanted to turn it back into scientific notation, it would be 8.7 times 10 to the 4th. All right, there's your, hopefully you can do well tomorrow. You don't need to get them all right. I'm just going to see which topics you still need help on after tomorrow. All right, good luck.